Hello everyone. Today I am here again with second session of circle chapter where I will be discussing problems based on circle. In our last session we had discussed the basics of circle, then we also saw the theorems based on circle and some important point we studied. So let's start with the problems based on circle where we'll be discussing questions which is based on tangents and the related concepts. So starting with the first question, here the question is, from a point Q, the length of tangent to the circle is 24 cm and the distance of Q from the center is 25 cm. Find the radius of the circle. So let's find it out. Here it is given the length of the tangent is 24 cm and the distance of Q from the center is 25 cm. Now if we'll check in triangle POQ, we know that angle P is 90 degree here, so we can use the Pythagoras theorem and we can write here as PQ square plus OP square equals to OQ square. That means OP square will be equals to OQ square minus PQ square. Here OQ is 25, so it will be 25 square minus 24 square, which we can write it as 25 plus 24 into 25 minus 24. So the value of OP will become square root of 49 into 1, which will be 7 centimeter. Moving to the next question. The question is, if the tangent PA and PB from a point P to a circle with center O are inclined to each other at angle of 80 degree, then find angle POA. So let's draw the circle, and in this case we have two tangents PA and PB. It is given that they are inclined to each other at an angle of 80 degree. So here this particular angle is 80 degree. We have to find angle POA. So here it is the center, this is O. So in this case, what we know is that here angle APO, that will be half of angle AOB, which will be equals to half into 80, that will be equals to 40 degree. And now if we'll take in triangle AOP, we can write that 40 degree plus 90 degree plus angle POA will be equals to 180 degree. We know that angle between the radius and tangent at the point of contact is 90 degree. So from here angle POA will be equals to 180 degree minus 130 degree, and so the value of angle POA will be 50 degree. Moving to the next question. It is given that two concentric circles are of radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. In this case, let us suppose these are the two circles where AB is the chord, O is the center of the circle, and radius of larger circle is 5 cm and for the smaller circle it is 3 cm. We have to find the length of the chord. So in this case, as we know angle between the radius and tangent is 90 degree, let this point be P. What we can say that in triangle AOP, we can write that AP square will be equals to OA square minus OP square by Pythagoras theorem. That means it will become 5 square minus 3 square, which is 25 minus 9, it is 16. So therefore the value of AP will become root 16, which is 4 centimeter. We are not considering the negative sign as length cannot be negative. Now we know that if you draw perpendicular from center to the chord, it bisects the chord. That means the value of AB will be equals to 2 times AP, and so the length of the chord will be 8 centimeter. Let's talk about the next question, where it is given that a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD equals to AD plus BC. So in order to prove it, we'll take the help of the length of tangent concept, where we have studied that if you draw tangent from the exterior point of a circle, then length of tangents will be equal. So in this case, if you talk about point A, so we can say that AP equals to AS, as it is length of tangent from A. Also we can say that BP equals to BQ, it is length of tangent from B. Further, we can say that CR equals to CQ, that is length of tangent from C. And we can also say that DR equals to DS, which is length of tangent from D. Now once we have written this, now if we'll add all of these, adding all, we get AP plus BP plus CR plus DR equals to AS plus BQ plus CQ plus DS. Now here if we will add AP plus BP, we'll get AB, and CR plus DR will be CD, which is equals to, if you add AS and DS, you will get AD, and if you add BQ and CQ, you will get BC. So this will become AD plus BC, and this is what we had to prove. Now, moving to the next question, the question is that in figure, it is given that xy and x dash y dash are parallel tangents to a circle with center O, and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is 90 degree. In this case, it is given that xy is parallel to x dash y dash. We have to prove that angle AOB equals to 90 degree. Now to prove that, we'll do a construction that will be join OB. Now here, for easy writing, we'll take this angle as 1, 2, 3 and 4. So what we observe here is, if you will take in triangle AOP and triangle BOA, what we'll get is, we'll have PA equals to PB, that will be length of tangent from A. And then we know angle OPA will be equals to angle OBA, which will be equals to 90 degree, and here OA equals to OA, that is common. Therefore we can say triangle AOP is congruent to triangle AOB. We can say angle 1 equals to angle 2. Similarly, we can say that triangle BOC is congruent to triangle QOC, and which implies that angle 3 will be equals to angle 4. Now, we know that tangents are parallel, that means PQ will be a diameter. So in this case, angle POQ will be 180 degree, which can be written as angle 1 plus angle 2 plus angle 3 plus angle 4, which is 180 degree, which can be written further as 2 times angle 2 plus angle 3 equals to 180 degree. So angle 2 plus angle 3 will be 90 degree, and so angle AOB will be equals to 90, as we'll be replacing angle 1 with angle 2 as angle 1 and 2 are equal, and we'll be replacing angle 4 with angle 3 as angle 3 and angle 4 are also equal. We'll obtain 2 times angle 2 plus angle 3 equals to 180, and so we'll get angle AOB equals to 90 degree. Moving to the next question, where we have to prove that a parallelogram circumscribing a circle is a rhombus. So let's take ABCD is a parallelogram, and PQRS are the point of contact of the circle with the parallelogram. In this case, it is given that ABCD is a parallelogram. Required to prove is ABCD is a rhombus. That means we have to prove that its adjacent sides are equal. Now to prove it, we'll say that here AP will be equals to AS, as it is length of tangent from A. We can say that BP equals to BQ, it is length of tangent from B. We can say that CR equals to CQ, which is length of tangent from C, and we can also say that DR equals to DS, which is length of tangent from D. Now adding all, we get AP plus BP plus CR plus DR equals to AS plus BQ plus CQ plus DS, which will give us AB plus CD equals to AD plus BC. And as we know, in parallelogram, opposite sides are equal, so we can write it as 2 times AB equals to 2 times AD, which implies AB equals to AD. And as in this case we see here that in a parallelogram adjacent sides are equal, so we can say that therefore ABCD is a rhombus. Moving to the next question, a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which BC is divided by the point of contact D, are of length 8 cm and 6 cm respectively. Then find the value of AB and AC. So in order to solve this particular question, we will take the side AB as C, BC as A, and AC as B. Now here what we can see is, let's take this point of contact as E and this point of contact as F and join it to the center. So here what we'll observe is OD will be equals to OE will be equals to OF. All will be equal to 4 cm, as it is also the radius of the incircle. Here also we can see that the value of CF will be equals to CD, which will be 6 cm, and the value of BD and BE will be equal, which will be equals to 8 cm. In order to find out the side length AB and AC, we'll have to find AF and AE value. Let AF, which will be equal to AE, as it is the length of tangent from the exterior point, and the value of it, let it be x. Now, in order to solve this particular question, we are going to use the Heron's formula and the area of triangle formula. So what we'll do here is, we will join OB, OC and AO. So what we'll have to do is, first of all, we'll find out the semi-perimeter, which we'll be using in Heron's formula. So here the semi-perimeter value will be equals to AB plus BC plus AC divided by 2, which will be equals to, the value of AB is x plus 8 plus the value of BC is 14 and plus the value of AC is x plus 6 divided by 2, which will be equals to 2x plus 28 divided by 2, and that will become x plus 14 centimeter. Here we'll take, let A equals to 14, B equals to x plus 6 and C equals to x plus 8 centimeter. So what we'll observe here is that area of triangle ABC, which will be equals to area of triangle AOB plus area of triangle BOC plus area of triangle AOC, and that if we use by the Heron's formula, we know the area of triangle will be S into S minus A, S minus B, S minus C, which is equals to half into, for triangle AOB, base will be AB, height will be OE, plus half into, for triangle BOC, base will be BC and height will be OD, plus for area of triangle AOC, half into, base will be AC and the height will be OF. Now when we substitute the value, we will get S as x plus 14 into S minus A, that is x plus 14 minus A is 14 into x plus 14 minus B, which is x plus 6, it will become x minus 6, and into S minus C, that will become x plus 14 minus x minus 8, which will be equals to half into AB is x plus 8 into height is 4 plus half into BC, which is 14 into height is 4, and plus half into AC is x plus 6 into height is 4. Further, on solving this, we'll get square root of, here 14 and 14 will cancel, x and x will cancel, x and x will cancel. We'll get x plus 14 into x into 14 minus 6, it will be 8, and 14 minus 8, it will be 6, which is equals to, we can take half into 4 common, we'll get x plus 8 plus 14 plus x plus 6. Here we can cancel it 2 times. We'll get a square root of 48x into x plus 14, which will be equals to 2 times 2x plus 28. Now if you square both sides, what we'll observe is we'll get 48x into x plus 14 equals to, if you'll take 2 common here, it will become 4 into x plus 14 whole square, which when we solve, we'll get 48 into x plus 14 equals to 16 into x plus 14 whole square. Here we can cancel x plus 14 and 1 of the power. 16 will cancel it 3 times, and the value will be equals to 3x equals to x plus 14, which implies 2x will be 14, and so the value of x will be 7 centimeter. Now we have to find the length of AB and AC. So what we can say here, that AB is x plus 8 and AC is x plus 6. On substituting the value of x, we'll get the values of AB. So therefore, the value of AB will become x plus 8, which is 7 plus 8, 15 centimeter, and the value of AC will be x plus 6, which will be 7 plus 6, that is 13 centimeter, and that will be the value of AB and AC. The next question is, prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So here what we have to prove is, required to prove is the first one. If we'll take the center of the circle as O, angle AOB plus angle COD equals to 180 degree, and the second result what we have to prove is angle AOD plus angle BOC is also 180 degree. That means opposite side subtends supplementary angles at the center. To prove it, we will join OQ, OP, OS and OR. Now in this case, what we'll do is, if we'll compare in triangle AOP and triangle AOS, we'll get OP equals to OS as it is the radius. We'll also get OA equals to OA, that is common, and we'll also get AS equals to AP, that is length of tangent from A. So therefore we can say that triangle AOP is congruent to triangle AOS by SSS criteria, and so if we'll take this angle as 1 and this angle as 2, we can say angle 1 will be equals to angle 2 by CPCT. Similar way, if we'll take these angles as 3, 4, 5, 6, 7 and 8, what we observe is that similarly we can say triangle BOP will be congruent to triangle BOQ, and so we can say that angle 3 will be equals to angle 4. Triangle COQ will be congruent to triangle COR, and so we can say that angle 5 will be equals to angle 6. And triangle DOR will be congruent to triangle DOS, and so we can say that angle 7 will be equals to angle 8. Now we know that central angle at O is 360 degree. That means angle 1, 2, 3, 4, 5, 6, 7 and 8 will add up to 360 degree. So if we use that, we'll get angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, angle 6, angle 7 and angle 8 equals to 360 degree. As we know that angle 1 and 2 are equal, so what we can write in this case is that angle 1 equals to angle 2 plus angle 2, angle 3 will leave as it is. If you take the help of the diagram, then we will prove first angle AOB plus angle COD is 180. So angle 4 will replace it by angle 3 plus angle 5 will replace it by angle 6. Angle 6 will leave as it is. Angle 7 will leave as it is, and angle 8 will replace it by 7, which will be 360 degree. Which means we can write 2 times angle 2 plus angle 3 plus angle 6 plus angle 7, which is 360, we can cancel it. 180 degree times angle 2 plus angle 3 will give us angle AOB, and angle 6 plus angle 7 will give angle COD, which is 180 degree. So this is the first part which we have proved. Then we also know that the sum of all the angle is 360. So here we can say that angle AOB plus angle BOC plus angle COD plus angle DOA is 360 degree. And as we know that AOB plus COD is 180, so we can say angle BOC plus angle DOA plus 180 degree equals to 360, and so angle BOC plus angle AOD will be equals to 360 degree minus 180 degree, which will be 180 degree. So this is how we can prove that angle AOB plus angle COD is 180 degree and angle BOC plus angle AOD is also 180 degree. That means they are supplementary. So this is all for this session. Thank you. Take care, everyone.